Hi, so now I'm going to start talking about differential equations. Differential equations are something in the format you see when you have, for example, an equation like f of x, right? And you differentiate this stuff with respect to x, and let's just call this f of x. So you're going to start with this, okay? Differential equations are equations where you have some kind of derivative in the middle of the equation. So for example, I'm calling, dy dx, I'm calling this y prime. And d squared, the second derivative of y with respect to x, which has this notation, I'm going to call this y double prime, okay? And so on. So this is the second derivative. Okay, so for example, if you have an equation like x squared plus 3x cubed minus 5x plus 3, that's not a differential equation because nothing in here is a derivative, right? This is just a regular equation. Now let's just say that besides all this, you also have something like, I'm going to put a plus in here, and in here I'm going to say the second derivative equal to 0. Okay, so you have the second derivative of y. Now what is y going to be? Y is going to be some function of x. Okay, so that function of x, the second derivative of that function of x plus all this stuff equals 0. Now this is a differential equation. Okay, now differential equations can be classified. So the first one is partial versus ordinary. Hold on. Okay, so ordinary differential equations is when you have these differential equations where the y in here depends only one independent variable. Because when you say, for example, y equals x plus 3, the independent variable is the x and the y is the dependent one. So if you put a 1 here for x, y is going to be 4. If you put a 2 for x, y is going to be 5. Now, okay. So in this way of expressing the equation, because you can also say x equals y minus 3. Now, y is the dependent and y is the independent variable and x is the dependent variable. Okay. Now, but for now we're just expressing the equation like this. So x is the independent variable and y is the dependent variable. So you can say that y is a function of x. Now let's just say that you have something else like a z equals f of x and of y. So you have something like x squared minus 5y plus 3. Okay, so you can see that z depends on x and y. It's an equation that depends on two independent variables. You can put some values for x and you can put some other values for y. And once you do that, you're going to have an according value z. So z is the dependent one, x and y are the independent one. So in this differential equation right here, if y is just a function of x or a function of t or a function of theta, but there's only one independent variable, you call this ordinary differential equations. Ordinary differential equation. If it depends on two independent variables, then it's a partial differential equation. Why? Because for you to derive, for example, differentiate this stuff, it's just going to be equal to 1, right? In this case right here, y prime is 1. Now, in this case right here, you can differentiate with respect to x, and then you can differentiate with respect to y, okay? And the way to differentiate the z is like dz dx plus dz dy. So first differentiate z with respect to x, which is going to be, I'm just going to get ahead of myself here. So this is a constant and this is also a constant with respect to x. So it's going to be 2x, right? And now you differentiate it with respect to y. So this is a constant with respect to y and this is also a constant. What's going to matter when it's with respect to y? It's this. So it's going to be minus 5. So this is a partial differential equation, okay? because you have to partially differentiate with respect to x, and then I have to partially differentiate with respect to y. All right, so this is the difference between ordinary and partial differential equations, okay? The ordinary one, you're just going to depend on one independent variable, and in the partial differential equations, you're going to depend on more than one independent variable. Okay, there's also first order and second order and higher orders. So for example, this is a second order differential equation. Why? Because the highest derivative in here is 2, okay? If it were just 1, like, I'm going to erase this stuff in here, like that. Now this is a first order differential equation because you're just differentiating whatever term in here just once. You have linear and non-linear, okay? Now, for example, this is not non-linear. It's non-linear because you have something here squared, you have something here that's cubed, okay? But there are other ways that you can have a linear is if every term in here is just to the power of 1. So if the equation were just like this, I'm going to erase these two terms. Now it's a linear differential equation. This is elevated to 1. Even if it's a second, okay, second order or a third order, this is still a linear differential equation because it's to the power of 1. This is to the power of 1. This is to the power of 1. This, okay? So this is a linear differential equation of third order. Now this one here is the nonlinear differential equation of first order, okay, because you got a first order in here. And there are other ways too that you can have a nonlinear. I'm going to show, for example, I'm going to say, for example, y prime plus 1 divided by x. This is a nonlinear because this is the same thing as y prime plus x to the minus 1. So it's not being x to the 1. Everything here is not being elevated to the power of 1. Okay, so this is nonlinear. Another way that you can have nonlinear is, for example, when you have squared and cubed. Another way that you can have nonlinear is when you have trigonometric stuff. So for example, y double prime, well, I'm just going to say y prime minus the sine of x. Okay, now this term in here is nonlinear. So this is a nonlinear differential equation of first order. And when you also multiply things, for example, you have these things in here, but this one in here, I'm going to multiply like this. Now you have a y prime times a y, okay? Or you have a y double prime times an x. So you have two things that are not, you're having a constant, you have a term that's not being just multiplied by a constant, okay? For example, when you have this, now, this term is just being multiplied by a constant, which is 1, okay? This term right here, actually, the constant is equal to 1. It was supposed to be minus 1, but it's minus 1 times the sine of x, and the sine of x is not a constant. So this is a nonlinear differential equation. The same thing in here, okay? Instead of being just y double prime times 1 or x times 1, what do you have? You have y double prime times x. So this is a non-linear differential equation. And the last category is like homogeneous times non-homogeneous differential equation. Homogeneous, when you have a differential equation where every term is together to the power of n. Okay? So for example, let's just say that you have x cubed or minus, right? Minus y cubed plus x squared y. You can see that when you add all the exponents, everything is going to be to the power of 3, right? Because you have a 3 here, you have a 3 here, here you have a 2 plus a 1, which is also a 3, minus xy squared, right? Plus x double prime, or I'm going to say triple prime squared, and y, for example, or it can be an x. So all these are 3. You got 3 here, 3 here, in here you have 2 plus 1, 3, In here you have 1 plus 2, 3. In here you have 2 plus 1, 3. So this is a homogeneous differential equation. And a non-homogeneous differential equation is when one of the terms, this is a term, this is a term, this is a term, one of the terms is different from n. Okay, you have one of the terms elevated to the power of n, and you got another term elevated to a different power. For example, the power of m. So this is that will be a non-homogeneous differential equation. For this, I just wanted to make an introductory video. So I'm gonna post this stuff, and we're gonna go to the exercises on the next video.